Today's tutorial is about finding the local maximum, local minimum, and zeros of a graph. So the local maximum and minimum points are the largest and smallest points within a given range, and the zeros are when the graph touches the x-axis, or basically the y value is equal to 0. So for example, in this graph, um, if we take this specific range, then the local maximum point will be somewhere around here, since it's larger than all of the points around it. So to use your calculator to find these points, you can first plot the graph, which I already done here, and then you would go to Menu, Analyze Graph, and then here the first three options are 0, minimum, maximum. So for this one, we're going to be starting with maximum, since it's the most obvious where it is. So you would just have the dotted line to the left of where you know that the point is, and then you click and then drag it so that the gray shaded area covers the section, and then you click again, and then it shows you the point, the coordinates of the point, which is shown here, 1.73, negative 13.9. And then to find the minimum, it's pretty weird that on the exam paper, on the exam question, it shows like this, that it dips below the x-axis, but it doesn't show on the calculator. But that sometimes happens, so you would just still do the same thing. So I would just change it this time to minimum, and then drag across the whole thing, and then there we go. It shows that it's negative 1.73 and negative 0.072. So then for the zeros of the graph, here we can see that there's one point which touches the x-axis and another point. So then you can do the same thing again, but with the zero function. So I would first start off at the most left of the graph and then start from there, and then drag until I get a point. So here, once I get this point, I'll just stop. And then, so now we know that one of the zeros is negative 3, 0. And then, since I know that this point has to be the one on the left, I can just use this one again, but then I start the line like to the right of that point, so it doesn't so that point doesn't interfere with the next one. So then I drag, and then there we go. It shows that it's the second one is negative 1, 0. So now that you know how to use your calculator to find these points, I would like you to try this example question from a past paper for extra practice. So you can pause the video, and once you're done, you can continue watching. Okay, so the first step to solving these kinds of questions would always to be graph the function, which is pretty simple. Just do 2x cubed minus 5x squared plus 3. And since it tells you like the range and domain for the graph, you can basically just set your window settings to match theirs. So x min will be negative 1.5, x max will be 3, y min will be negative 15, and y max will be 15. So now that you have this, you can just sketch the graph, which is like this, something like that. And B asks you to find the zeros of f of x. So you can just use the zero function to do that, and then we can see that there are 3 zeros since 3 points touch the x-axis, so we can just do them one by one. So first one will be here. Shows you that it's negative 0.686. So you can write x equals negative 0.686. And then for the next one, you just repeat the same step, but do it for the next point. So this one would be 1. X equals 1. And for the last one, x will be 2.19. It's 2.19. So for the next one, it asks you to find the local maximum. And since the local maximum is the largest point within a given range, we can basically decide that it's probably going to be this point, since it's kind of where the graph peaks. Like after this point, the graph starts going down. So we can just go over this point, and it shows that it's 0, negative 3. So I would write 0, 3. And finally, for the local minimum, since this point, the graph goes down to this point, and then after that, it goes back up. The point around this area is going to be the smallest one. So we can move these out of the way and just use the minimum function and highlight this entire area, and that shows that it's 1.67 and negative 1.63. And that's it. Thank you for watching.